This is Professor Thompson, and this is exercise 7 in section 3.5. And so this is some review on inverse trig functions. And I just want to simplify this expression, or I guess in this case they give you the answer. I want you to prove that cosine of inverse sine of x is equal to the square root of 1 minus x squared. And so what you should start with is sine inverse of x. What that means, if that's some answer, we'll call it theta instead of y to make it more clear. That means that x is sine theta, right? But it also means that theta is in the range of inverse sine, and that means that theta is between minus pi over 2 and pi over 2. So we're talking about the region where, if you look at the unit circle, we're looking at this region. So in the first quadrant, everything's positive. In the fourth quadrant, cosine is positive with sine and tangent aren't. But sine of theta, if you want to write that as a ratio, you can think of that as x over 1. So that's all the information I need. So I'm going to go ahead and move to a new slide so that I can draw a triangle. So if sine of theta, in this case, is x over 1, then that means the opposite side from theta is x, and the hypotenuse is 1. And so then I've got this last angle, which we'll call y. So that means that 1 squared equals x squared plus y squared. So y then is 1 minus x squared, or y squared is. And now I'm taking a square root, and I know that this is a positive square root because we saw from a minute ago that we're looking at the region minus pi over 2 to pi over 2, and that's where cosine is positive. So down here I can write the square root of 1 minus x squared, and I know that that should be positive, because that way the cosine of theta is the adjacent side, square root of 1 minus x squared, over the hypotenuse, which is 1. So the answer here is just the square root of 1 minus x squared, like we wanted. So that's exercise 7. Now we'll look at exercise 9, which is similar. Exercise 9 is the sine of inverse tangent of x. And I want to simplify this. And so they want it without trig. They want a rational expression. Well, let's begin with the same idea. In this case, inverse tangent can take on any value, so I don't have to worry so much about that. But to say that inverse tangent is theta is that x is tan theta. And we can call that x over 1. So that means that if I have a triangle here, I've got theta, the opposite side is x, and the adjacent side is 1. So that means I have x squared plus 1 squared equals h squared for the hypotenuse. So that would just be the square root of 1 plus x squared for the hypotenuse. And I take the positive square root here because the hypotenuse is always positive. And so now that's how my setup is. I now want sine of theta, and that's going to be the opposite, which is x, over the hypotenuse. So 1 plus x squared square root. And right there should be my answer.